Okay, dear student, in last lecture we already see the difference between the distance and displacement. Today we are going to solve some example that how the distance and displacement are different mathematically uh, here. So for example, this is the example number one. An object move from point A to C along the rectangle shown in the figure below. Here the rectangle is given. Let's suppose here is one object and it is moved from A to C here, like this one. So they ask the question, find the distance covered by the moving object. Number first part of this example. The second part, find the magnitude of the displacement. So the distance is very simple. We say that the total path covered by the object. So the total part when the object first move from point A to B, this side, and from B to C, this side. So from A to B, total distance is 5 meter plus B to C 3 meter. So 5 plus 3 meter is equal to 8 meter. So the distance is very simple. The total path is 8 meter. Now displacement, we know that the shortest distance. So in displacement we know that there are also one way is possible from A to C. One way is this longest path. The other one is the shortest path from A to C, mean the diagonal of the rectangle. So now this side is AC, this side is AB, and this side is BC. So we will apply the Pythagoras theorem to find the magnitude of displacement. Very simple. This side is unknown. AC square is equal to AB square plus BC square. So the two side is given. So this side is AB is 5 meter square plus BC is 3 meter square. So now the AC square is equal to this side is 25 plus 9. So now I'm going to solve this question here. So AC is equal to 25 plus 9 is 34 meter. Now taking the square root on both sides, so this is equal to 34 meter under the root or square root. So AC is equal to 34 meter under the root. So this is the magnitude of the displacement. So this is the difference. So this is the shortest way and this is the longest way. The longest way is distance and the shortest way is displacement. Okay, next example, let's see. They ask the question, a car travel along a straight road 100 meter toward east. For example, we have a car which is moving straight like this is the for the if the east, northeast and south is given for the simplicity, you can draw negative in east, south, west. So the car travel along a straight road toward east. Toward east how much? 100 meter, and then west 50 meter. So this is 50 meter. Mean the car stop again here and it is moving toward this direction. The distance is how much? 50 meter. So if we find the distance here, so very simple, 100 meter plus 50 meters, so which is equal to 150 meters. So this is the total distance. Now how can we find the displacement? Very simple. This displacement is equal to 100 meter minus 50 meter. So the remaining path is 50 meter toward which side? Toward east side. So we also gave the direction here, and this will show the displacement. So the total path in distance is 150 meter, but in displacement 50 meter. So this is the shortest and this is the longest. Okay, next one, next example. A person walk 4 meter east, then walk 3 meter north. Determine the distance and displacement. Again, here the east and north and so on is given. So for the simplicity, again we will draw the direction. This is east and this is south. This is west. So first they mention here 4 meter toward east, like here 4 meter, and then 3 meter toward north, like north. Toward north, this is 3 meter. So determine the distance and displacement. So here again they ask find the distance. So distance is very simple, 4 meter plus 3 meter, which is equal to 7 meter. Now how can we find the displacement? So this is the longest way, and the shortest way, this is the initial point, this is the final point. It's very simple, like this. We can make the triangle, and again we will apply the Pythagoras theorem. So displacement is equal to 4 meter square plus 3 meter square under the root. So this is 16 meter plus 9 meter under the root. So this one is if we add these two value, so the answer is 25 meter. And if we take the square root of 25, so this is equal to 5 meter. So the displacement is how much? 5 meter, and the distance is 7 meter. So this is the difference. This is the longest way and this is the shortest way, 5 meter. Let's see another example here. Okay, a runner travel around a rectangular track. Like this is the rectangular track. The length of this rectangle is 50 meter and the width is 20 meter. After travel around rectangle track 2 times, mean this is the starting point. They start the motion from, this is the one track, and again he will goes and stop here. This is the second track. So it's very simple. This side plus this side, we can also say 2 multiplied by 50, which is equal to the length is 100 meter, width is equal to, one is this side and the other one is this side, each side is equal to 20 meter. So again we can write 2 multiplied by 20, which is equal to 40 meter. So now one track is equal to 100 plus 40. If he start the motion from here and again stop here, so in one track their motion is how much? 100 plus 40 is equal to 140 meter. So in question they ask 2 track. If he complete the 2 track, mean 2 times if he goes here. So very simple. Total distance, we can say total distance 2 multiplied by 140. So the total distance is how much? 280 meter. So this is the distance. Now they ask the question like find determine the distance and displacement. So the distance is 240 meter. Now what about the displacement? The displacement is equal to 0. Is equal to 0 meter. Why? Because this side and this side is opposite and their magnitude is same. Like this is plus 50, this is minus 50. This is like to if we go downward, this is minus, and if we go upward, this is plus. So they cancel with each other, and the displacement, we know this is the vector quantity. So because of the vector quantity, each side will cancel with each other, like 50 minus 50 is equal to 0, 20 minus 20 which is equal to 0. If he continue this motion for 20 minutes, so till the displacement will equal to 0. Okay, thank you so much.